overdue part 6 in the Understanding Vacuum Tube Amplifier Schematics series. This one focused on the grounding of tube amplifiers. What happened was I'm working on episode 13 of the single-ended amplifier, the 807 build that I've got going. And I got into a section in there explaining grounding and how I was going to ground this amp. And the next thing I knew, I had built out quite a few slides about grounding. And then I thought, I should just pull this out of that video and pull it over here and make it a part of its own series on understanding schematics. So let's dive on in. Okay, so what the heck is ground? Other than the what we walk on when we go outside, but it's not a lot different in concept if you think about it. From an electrical circuit standpoint, ground is a common reference point of potential voltage assumed to be at 0 volts. It's not always the case. I've seen some military equipment and other things that ground is not actually at 0 volts for a variety of reasons, but the mass majority, probably 99.9% of the time, when you're talking about ground, you're talking about a potential point of 0 volts, and it is kind of a reference point that everything then ties back to. Okay, when we're talking about tube amplifiers, there can be a couple different types of ground scenarios. The first one we'll talk about is what we'll call earth ground, and typically that's the third wire found in U.S. house wiring. It's the green wire or green and yellow wire that comes in on your power cord, and typically you connect that as close to the chassis as possible where the power enters the amplifier. The purpose of this ground is really all about making sure that your chassis of your amplifier is at the same potential as earth ground, so that if you touch your chassis and maybe you were standing on a concrete floor that was damp or something, you don't end up getting shocked. Or if you have a cut in your wiring as it enters the chassis, it would short out there and cause your breaker to trip. So it's more of what we would consider a safety ground. Okay, up next we have what's typically called either chassis or power ground. And what that is when your power supply in your amplifier feeds voltage outwards to various components within the amplifier, they have to complete the circuit and get back to that power supply somehow. And that's typically done through what is called chassis or power ground. And then third, you can have something called signal ground. It's kind of a point that's either could be tied to the chassis power ground, or it could be floating at a different potential voltage. But it's the ground of the actual signal, the audio signal, and not necessarily the DC power supply. So if I haven't confused you enough at this point, let's walk through some examples that'll help bring a little clarity. So let's first talk about logical. So typically when we draw a schematic, that is a logical diagram, not a physical diagram of something. And basically here we're showing a DC power source on the left. That could be a battery, a power supply, whatever. And you've got your voltage that leaves the positive terminal. Typically, if you follow conventional current flow, it then flows, from positive to negative. It goes through the load, whether that's a resistor, a tube, or whatever. It flows through that, and then eventually it has to make its way back to the original power source. If it doesn't, then you don't have a closed loop circuit, and basically you don't have current that flows through there. So typically this return path that I've got highlighted here in yellow is at 0 volts, and that's what we're talking about when we're talking about ground. So typically you would say this is the positive side of the power supply, this is the ground side. You're going to feed out through whatever load, and then you're going to come back to ground, and it'll find its way back to the DC power source. Well, keep in mind, if you have a power source over here and you're feeding out and coming through a load, whether that's a tube, a resistor, a speaker, whatever it is, you've got to find your way back down to this ground point and back to the battery. So you could consider this a circuit. Here, you'd have to find your way through this resistor and back. That's a circuit. You'd find your way through this resistor and back around. That would be a circuit. And then this area here that we're highlighted, that's typically called the ground. And sometimes this can be tied to the chassis. Sometimes we handle that other ways. Here's a great example of just an amplifier schematic, and you can see here in one place they're tying all these points to a common ground over here. But at other times it's not so easy to draw a schematic and tie the grounds back down here. Like this capacitor is tying to ground here, as you can see. And oftentimes it's hard to draw a line down, jump over this one and come through. So they'll just show it here as a separate connection point. Do not assume that on a schematic, if it has a separate connection point, that it is a separate physical connection within the amplifier. It very well may be tied right here onto the same little bus, the same over here with this output. And we'll talk about that more here in just a little bit. And coming back to this slide, I forgot to cover this. A couple different symbols here for the earth ground, chassis ground, signal common ground. Sadly, these symbols are used so interchangeably that they have lost their distinct meaning. If you remember this schematic, they never once showed a chassis or earth ground. They just showed a signal ground here from the way that symbol was designed to be used. But you just have to get used to, people use different flavors of ground, just like they use different capacitor symbols, so on and so forth. And here's a different example where every single ground point in this amplifier is drawn as a separate little entity here. You just got to realize that physically that may not be the case in that amplifier. I'll tell you, if you built this amplifier in a chassis and you grounded all these things at different points in the chassis, you would have ground loops all over the place, which would cause you lots of hum and issues. And if you're wondering what ground loops are, I'm going to show you. So what the heck is a ground loop, you may ask? Well, I kind of drew them out here on this little simple schematic. So we got a battery or a power supply. And you could call these resistors, or you could call them a load, whatever you want to call them. And basically you're feeding power out through this load, and it's making its way back through this circuit to the negative point here, or ground of this power supply. Same with this purple circuit here, coming around, making it back. Same with the blue, coming around, coming back. Same with the green. You've got to complete these circuits for current to flow through them and make its way back to the negative side of the supply. Well, if we took a look at this little segment from right here back to right here, you would have 4 different ground currents flowing through this little wire right here, connecting back to, and I kind of circled them here, and what I'm saying is you've got multiple ground loops feeding back through this one little wire segment, whereas here you would only have 3 ground currents flowing through it. Here you would have 2 ground currents flowing through it, and here you would only have 1 ground current flowing through it. This is very important in an audio amplifier. If you're talking about an RF amplifier, it's not that big a deal, but for audio amplifiers, this plays out to create very interesting scenarios within your amplifier. So while technically all of these points right here on this bottom bar here are at the same voltage potential of 0, you still got to worry about these ground currents flowing through there. And so when we start to translate this into the physical aspects of things, the way this kind of works out, this little red circuit right here, you would want that to be feeding all your power supply components, because that's where your heavy current draws are going to come from. And that's where your the majority of the variation of your current draw is going to come from. Secondly, followed by your power output tube. You would want it second in this series of grounding connections, because you do not want to take the significant current draws that happen right here as a result of your power output swings and drag them through your small signal circuit right here. Major changes in either the power supply or this power output tube, if they were feeding back through here, they could affect and or kind of modulate your signal here on your small little signal tube. So typically physically you kind of go power supply components, power output tubes, kind of driver and or phase inverters. Then you get into your small signal input and or phono tubes. So you want to keep these as far away from this power supply as possible from a physical standpoint. So you may ask, how is all this kind of handled physically within a tube amplifier? Well, first off, this earth ground we talked about, and that's kind of where you bring your power cord in, and you're tying your little green or green-yellow wire directly to the chassis of the amplifier. This is kind of designed to prevent electrical shock, and it can help reduce some RFI noise in your overall amplifier. Another common way is something called a star ground, a technique where you tie various ground return paths via single wires back to a common point. I'll show you some examples. A bus ground is where you use common wire to serially bring all components back to a common location. Ground plane is kind of a variation of the bus ground, but you typically see it on printed circuit boards. It's a large area of a printed circuit board that all points in that amplifier tie back to. And then you see some hybrid star and bus grounds, sometimes called multiple star grounds. A technique that uses both some star and bus ground methods effectively, and there's a lot of variations within this. And you see this done a lot, to be honest. And then last but not least, and probably my least favorite, is an all chassis ground. And that's where every single component in the amplifier gets tied back to the chassis. And then you're relying on the chassis to be your ground point. Very, very common to have ground loops in this scenario. And this would have been an example of that. Does not play out well in modern audio amplifiers, or especially tube amplifiers. All right, so let's take a look at examples of all these things. So I've used this little picture. It's in my notebook. I just take a picture of it every once in a while and throw it in. It's in several of my videos, but it's the back of an IEC connector, and it kind of shows you how you should wire up your fuse, your switch, your transformer, so on. But what we're talking about here is what's circled in blue. This is your little third leg of your power wire. That thing should be connected directly to chassis ground. And here's two examples of how that would happen. If you're not using an IEC connector, you would come through some kind of grommet, come into your amplifier chassis, and you take that third wire and go straight over here to ground. And typically you want to not only bolt it down, but solder it as well to give that thing a good solid connection. And here's another example of an IEC connection where they did what I'd shown and came straight into the fuse on one side. But this third little leg goes straight down here and it's bolted to the chassis. I like to try to solder them as well if you've got an iron big enough to do that, but if not, you can just bolt them down really well. Just make sure you use lock washers if you do. If this thing comes loose, creates a kind of a chassis hazard there for you. Okay, let's take a look at what we would call a star ground example. And you've got your power supply or battery or whatever over here, and you're feeding out through a load. And then you've got an individual ground wire that brings that back to the negative of the power supply. Similar to this load, you've got its own separate wire. Each circuit here has its own ground wire coming back. And so at this point right here, you're not feeding four different ground currents through this little section. Each one has its own individual wire for a ground current, and they're all tied back to a common point called a star ground. This would be your star ground point right here. And here's a good example you could see of that. This amplifier, you can see all these little gray wires coming back to a common point right here that's been bolted to the chassis, and this would be a star ground point. Here's another great example. People are using yellow and green wire to feed from various points in this amplifier all back to a common point here that is kind of grounded and soldered to the chassis at this point. Okay, I've seen star ground techniques involving one single point for all ground wires to come back to. I've seen them with 2 star points, 3 star points, in other words, multiple star points, and we'll talk more about that as we go. 1 star point, everything coming back to the power supply via their own separate ground connection, theoretically would be the best scenario you could think of. The challenge is it creates a lot of wiring complexity within your amplifier. You can see here in this picture I found someone is attempting to do that. They're bringing back the ground of every single one of these capacitors and other components within this amplifier back to the single star point right here. You can just see all the wiring kind of challenges it creates within an amplifier. You could have as many as 15 or 20 wires coming back to a single point. I will say that 2 ground point works fairly well, one for the power supply and kind of output tubes, one for the preamp circuitry. And sometimes you see 3 of them used, one for the power supply, one for the output one tubes, and one for the preamp circuitry. And we'll talk more about that. So some guidelines for star groundings. So if you're going to use a multi-point star ground, the first ground point, do not tie this to the same point as this little ground right here. Do not use this point or this point right here for your first star ground point. That should be its own separate connection, the earth ground should be. The first power supply capacitor negative should be physically closest to this ground point. So in other words, you're going to have to make a chassis ground point as close as possible to the power supply capacitor negative, and you're going to kind of connect those together. That is the most important thing. And then your power supply transformer center tap should be tied there. Your filament center tap should be tied there unless it is elevated. And you would tie the remaining power supply ground points back to this first ground point. So if you're only going to do a 2-part, if you're only doing a single ground point, you would bring everything else in the amplifier back to this same point. If you're going to do a 2-star ground point, if you're only using 2 stars, the power tubes should go to this first ground point, and then the preamp, driver, phase inverter, and input tubes would all go to a 2nd star ground point, somewhere neutral, I would call it in the middle of all of those devices, and you would also ground the input jacks to that point. And each ground point would be located closest to those two. Each ground point would be located closest to those 2 ground points. So if you're going to do a 3rd one, you basically would use the first one for the power supply and the output tubes. You would use the 2nd star ground point for the phase inverter and or driver tube, and the 3rd one for the input tubes, and then you would also ground the input jacks to this point. Each ground point would be located closest to those 2 ground points. So in other words, physically as close to those points as possible. All right, let's look at some bus ground examples. So what is a bus ground? And sometimes it's called a bar ground, but that's where you use a single wire like we had drawn in our earlier schematics, this yellow highlighted piece, and it becomes your common point to tie everything back to in kind of a serial fashion along your amplifier. Okay, so here's an example of a bus ground. A lot of times they'll use what's called Romex wire, just standard old house wiring. This can be anywhere from 10 gauge, 12 gauge wire run along here, just stripped solid copper wire. And you can see how this tube here, you can see its cathode resistor ties to ground here. You see its cathode bypass capacitor ties to ground here. You can also see this tube, same thing. You've got the cathode resistor, cathode bypass. And if you'll notice this little terminal strip right here, it has the ground bus here tied to it, but it's not tied to the leg that's holding it to ground. In other words, this thing is just here for physical support, not actually tying it down to ground at that point. The same here, this is physical support. And you can see here that then this thing feeds over to this tube where you've kind of got the input grounds coming down to. You can also see this bus then feeds over to another point here, which is likely the power supply. But it's a good example of a bus ground. Okay, you can see an example here in a guitar amplifier. Someone's using a turret board here. It could be done with a tag board. But you can see a common point right here, all along here, is being tied together with wire, a single wire, and that becomes a ground point. So you've got various points in the amp that are needing to get to this ground bus, and they're just feeding across from one turret to another and then tying off. So very, very commonly seen in guitar amplifiers. Okay, not always is this bus one single linear piece of wire. You can see this one starts over here at the input jacks and feeds along, comes over here around through some circuitry, and then it turns and feeds over here, comes back around to, looks like part of maybe part of the power supply here, as well as the same thing happens on the other side. You're feeding around over here and then you're tying it off. And what I'm starting to say is you're starting to see a little bit of a combo here of some buses, but some star points along those buses where multiple things are tying to kind of a star point. And so you're starting to see what would be called a hybrid here of star and bus. And a different take on a bus ground and a circuit board would be a ground plane. So all this outer blue area here that I'm kind of wiping along, all out here, around over here, up in through here, down in through here, all of this is a common ground. And so like this 100 microfarad capacitor, you can see it's timed from this positive point here over to ground, positive point here to ground, positive point here to ground. Same thing, but you can also end up with ground loops running around on these little chassis. So you got to be careful on how you lay these things out. So some guidelines around bus grounds. First, you should follow the schematic serially from the power supply all the way to the input jacks. You should start your bus on one end at the first power supply capacitor negative post, and then it should end all the way at the input jacks ground. And the various sections should go in this order along that way. So leading off of that first power supply capacitor, you should then go to things that ground related to the output tubes, then to the driver tubes, then to the phase inverter, then the input tubes, all the way then, like we talked about, to the input jacks. This is the most important thing about a bus ground. Only connect your bus to one physical ground point on the amplifier. If you don't, you will create multiple ground loops within this amplifier. So you can either do that in one of two places, either right at the power supply capacitor negative, so you could just come right off of that capacitor negative terminal and go straight down onto the chassis and kind of ground things, and then you would tie all those things we talked about earlier to that. Or you can also do it all the way at the input jacks, but not both. If you ground the bus at the power supply capacitor, sometimes there's two rules you need to kind of follow. You need to use isolated input jacks. In other words, the input jacks, as the little outer part of the RCA connector comes through the metal chassis of your amplifier, it has to have something there, either plastic, nylon, or something that isolates it. If the outer part of the jacks are grounded to your chassis, then you're grounding this bus on at 2 points. And then second off, you may need to put like a 0.01 film capacitor between the input jack's ground and the chassis at that point if you're starting the bus back at the power supply, and that is to help eliminate some RFI or EMI that RF may jump onto your RCA cables as they're feeding in, and then that kind of gets running around in your chassis at that point from a ground standpoint. So that 0.01 film cap can help eliminate or reduce that. Okay, an example or two of what you would call combination star and bus grounds, and there's a lot of flavors of this out there. So one is you could take all these power supply components, kind of tie them together to a single little bus here, but then you take those and tie them to the chassis at a single star point. Similarly here, you could bring all these together. So you could almost consider this a little star point, this a little star point, this a little star point, but you may be using a little bus in between here to then connect them down to that star point. And I just kind of represented here a power supply, capacitor, resistor. Maybe this is not a resistor, maybe it's a tube capacitor. Similar, you kind of get the idea. And this being your RCA input over here, with the ground of it might tie down here with your input tube to a single point here. Here's a great example of a Fender 5F1 Champ amplifier. And you can see here on this thing, it has several different kind of bus grounds on this thing that are tied off at different points. You can see the power cord coming in over here, going straight to the safety ground. That's its own little connection. But then you can see that the power transformer here, it's kind of coming over here, feeding into the negative of these caps. And so right here, you've kind of got a your own little, you can see it here, it says power amp ground bus right here. And then you can see here, you've got your preamp ground bus. So a whole different set of things feeding the preamp tubes here, or separate ground. And then you can also see your input jacks are tied to this ground. So in this case, you got one bus ground here, you've got another bus ground here, and kind of keeping the power supply and the power tubes separate from the preamp sections. All right, and last I'm going to leave you with some just additional guidelines regardless of the ground topology, I would call it, that you use. First off, output transformers, the common of those should be tied directly to the amplifier's output jacks. Do not tie it down to the chassis ground and then go from the chassis ground on another point to the output jacks. It will create a major ground loop. Do not tie the output ground jacks to the chassis at all, is a good rule I like to follow. And do not route output transformer wires anywhere near preamp tubes. It's not really a grounding statement, it's just a good general statement about output transformer wires. If you're using shielded wiring, so you went out and found you some really nice, sexy PTFE silver Teflon coated grounded shield wire, and you're using that to run your signals throughout this amp, only ground one end of that. Do not ground both ends. That will create another path for grounds within your amplifier. If you're using multi-section caps, in other words, can caps, you got to be careful, because they force you to use a single ground point at one point. So whether you like it or not, that can is your star ground point. So you got to be careful on the multi-sections inside of that, where you use those capacitors within your amplifier, because if you're not intending for those to tie back to that first ground point, star ground point, you can inadvertently make that happen. For earth ground, make sure the connection is as short as possible and as close to where the cord enters the chassis or right beside that IEC connector. It is best to solder all ground connections to the chassis or to each other or wherever you're connecting them. Do not rely on bolts and nuts to provide a solid connection or to not come loose. They will. And avoid using your chassis as your bus, grounding each component to it wherever they are located. This will likely cause you ground loops. It's an okay for RF, not so much for audio. Okay, if you want a better example, follow me over to episode 13 of my single-ended amplifier build as soon as I get it posted, hopefully this weekend. But you can see here, this is the kind of stuff I aspire to one day. I don't know if I'll ever get there, but you can see these just beautiful bus wires tying these capacitor grounds together, tying these resistors together. It just this is a great example of some beautiful bus wiring on this thing here. But thanks for watching, everybody. I hope you learned something, and if you got questions, please post them. We'll try to reply to them.